Right. Okay, so 6.1, we are on page 394. We're on page 394. Okay, let's go ahead and we're talking about polygons. Polygons is a triangle, rectangle, quadrilateral, all these things. You've heard these things before, right? You've heard about them, and you've kind of talked about them. All right. So let's kind of look at what let's say that we had a polygon that looked like this. Okay, so this would be what would you call this? Does anybody know what this is called?
A pentagon.
It's a pentagon, right? Because it has 5 sides, right? A pentagon. If it had 6 sides, it would be a hexagon, right? If you had 8 sides, it would be an octagon, right? You've heard these things before, right? Okay, so each one of these things are called a vertex, just like they were in a triangle. These are vertexes, right? Or vertices, I guess. The plural form would be vertices, okay? A line like this is called the diagonal, right? And obviously each of these little lines are going to be a side, right? Okay, all right. If you look at the middle of page 394, there is that nice little table that always shows up at this time, where you have triangle, quadrilateral, pentagon, hexagon, on and on and on and on and on. Okay, all right? You do not need to memorize this, okay? That's silly. We won't do that. Okay, example number 1. Go to example number 1. Tell whether each figure is a polygon. If it is a polygon, name it by the number of its side. Okay, we had the polygon, right? We had the pentagon, right? B is not a polygon, right? Why is it not a polygon? It's 2 triangles, really, right? Because their sides are, the diagonals are interlapping there. And then you have the polygon that is an octagon, okay, on C, that's an octagon, right? Okay, so that we will classify those by concave and convex. Okay, so what you are normally used to, the one that I drew before, something like this would be a convex, okay? A concave is if you had something that looked like this. If you had something that looked like this, okay? All right, where it's inside out, right? Where you have something that looks like that. Okay, the concave, if any part of a diagonal contains points in the exterior of the polygon. I have a diagonal here from vertex to vertex that is external to the sides. Okay, so that would be a concave. So something like this would be a concave. Okay, all right. Difference between a convex and concave. Example number 2. So you look at those A, B, and C, which one is going to be the concave? It's going to be C, right? See the one that looks like a 4-pointed star there, right? That would be a concave, just like this. Okay, so that would be a concave. All right, so now let's talk about finding the angles, some of the angles in a polygon, right? If I had a triangle, what are the sum of the 3 angles here?
180.
180, right? 180. If I had a quadrilateral, they add to 360, right? Okay. And if you do this, you can develop the equation that's given in the book is that the number of sides minus 2 times 180 is going to be your total angles, okay? So again, the sum of the angles inside, right? So if a triangle, 3 minus 2 times 180 is 180, like we just said. Quadrilateral was 4 minus 2 times 180. 2 times 180 is 360, and on and on and on and on. Okay? So if you look at the bottom of page 395, it shows you this equation. And it says the sum of the interior angles measurement in a convex polygon, okay? Sum of the interior angles in a convex, like a normal one, the one that we know, ones that we normally deal with, the convex polygon, okay? Flip the page, go to example number 3. Example number 3, we have A, find the sum of the interior angles measures of a convex octagon. Octagon, okay? A, octa meaning 8. So it's 8-sided, 8 minus 2 times 180, right? 8 minus 2 is 6, 6 times 180, 1080, okay? Find the measure of each interior angle of a regular nonagon. Regular nonagon, okay? Nona meaning 9. 9 minus 2 times 180. So let's find the sum of the interior angles first, right? We're going to have 7 times 180. So guess what? It's this plus 180, right? 1260. Okay. And the question was asked, the question that we're asking is what is the each of a rectangular? So they want to know how large each of one of the angles are. So you have 9 of them, right? So you just divide this by 9. And you're going to get 1, 3, 6. So that's going to be 40, 140 degrees. Okay, 140 degrees. C.
Mr. O.
Yeah.
Sophie said she's in the waiting room. She accidentally got kicked from the meeting.
Got it. Thank you. C, find the measure of each interior angle of the quadrilateral PQRS. So in this one, we have PQRS. And we have, this is C, and we have 3C and 3C. So when you add these all together, they're supposed to be what? In a quadrilateral, right? Where n is equal to 4, 4 minus 2. 2 times 180, which is 360. So we add these all together, I should get 360. 3C, that's 6, 7, 8. I have 8 C's. 8 C is going to be equal to 360. C is going to be equal to 360 divided by 8. 45. So C is equal to 45. Okay, now let's see if what they asked for. What did they find? They asked for find the measure of each interior angle. So this one's going to be 45. This one's going to be 45. This one's going to be 3 times 45, which is 135. This one's also going to be 135. Okay? Okay, now in the bottom part of page 396, it gives us a new theorem there. So the sum of the exterior angle measures one angle at each vertex of a convex polygon is 360. So if I had this and the sum of the exterior angles, right? So the exterior angle, this guy, and this guy. If I add 1, 2, 3 together, I will get 360 degrees. Okay, it doesn't matter whether it's a triangle, whether it's an octagon, or it's a nonagon. It doesn't matter, right? So if I go here and I add this, and this, I'll get 360, okay? That's what they're saying, all right? Okay? So let's go and see if we can use that on example number 4. Example number 4. Find the measure of each exterior angle of a regular hexagon. Hexagon meaning I have 6 sides, which means that how many external angles am I going to have? Remember they said that there's going to be 1 on each vertex, right? So you're going to have 6 external angles, right? 6 external angles. And since it's a regular one, they have to add the 360. So just divided by 6, you're going to have 60 degrees. So each external angle is going to be 60 degrees. B, find the value of A in polygon RSTUV. RSTUV. So that is, what kind of shape is that? What kind of gon is that? Anybody?
Pentagon.
It's a pentagon, right? Because there are 5 sides, okay? So there are 5 exterior angles, right? One of them is 7A, the other one is 2A, the other one is 3A, 6A, and 2A, okay? So when I add these all together, I should get what? I should get 360, right? So 7, that's 9, 12, plus 8, so that's 20. I get 20. A is equal to 360. A is equal to 360 divided by 20, which will be 118, right? 0, 0 canceled out. 36 divided by 2 is 18. So the value of A is 18. Example number 5. Example number 5, we have the aperture of a camera is formed by 10 blades. The blades overlap to form a regular decagon. What is the measure of CBD? CBD looks like one of the exterior angles, right? They're one of the exterior angles. And since it's a regular decagon, that means that all 10 of the external angles are going to be the same. So since all of them are going to be the same, I have 10 of them. So if we call them X, it's going to be, when you add them together, it's going to be 360. Which means that X is equal to 36. So each one of them is going to be 36 degrees. So the answer should be 36 degrees.
Mr. Ron?
Yep.
Kayla told me she's in the waiting room.
Yes.
She got kicked out.
Why is everybody getting kicked out today? Is my connection a little bad? Is it a little choppier than normal? No? All right, okay. Well, looks like we're done. So let me go ahead.